All right, you guys have had a couple minutes here to work through this, and a lot of you have gotten there, okay? So that's good. Let's just run through it real fast to make sure everyone's on the same page. Ha ha ha. So, one thing to make sure of, again, remember, make sure that you answer the question. We are looking for the dimensions. That's important that you guys understand that term. The dimensions mean, in this case, the width and the length. Okay, or the width and the height. Alright? So width and height.
Why did they call the horizontal axis y and the vertical x? Just to come.
I don't know. Yeah, probably. Okay, so you guys recognize that that 24 in the middle equals x times y. And you also recognize that the total area, okay, the least amount of paper is the area. So the area is going to equal the length times the width. Well, if I look at the side with the x, that's x plus 3 times y plus 2. Okay? So we have x plus 3 times y plus 2. I'm going to go ahead and FOIL that out first. You could do this part in different orders, so that's okay. So that's going to be xy plus 2x plus 3y plus 6. And then this is where you say, okay, well, wait a sec. I got to get everything in terms of one variable. And it doesn't matter if you put everything in terms of y or in terms of x. I'll just put everything in terms of x by saying, okay, well, y is 24 over x. So now I'm going to plug that in to my area. And now my area will be a function of x because I have x times 24 over x plus 2x plus 3 times 24 over x plus 6. And of course I want to simplify that. So my area in terms of x is that here the x is canceled, so that's 24 plus 6 is 30 plus 2x, and then that's going to be a plus 72 over x, which is 72x to negative 1, since I'm going to differentiate. Okay? So does everyone understand how we got to this point?
Yes.
Okay? Now, if I'm trying to minimize the amount of paper, I need to find the minimum point of this function. So that's where our derivative comes in. Okay? A prime is 2 minus 72 x to negative 2. You set that equal to 0 and you get x equal to 6 or negative 6, but you know it has to be positive. So if x is 6, that means y has to equal 4, and these are all in inches. So the dimensions of the page are 6 plus 3. So our page needs to be 9 inches tall, and 4 plus 2, 6 inches wide. And that will minimize the amount of paper that I need to make this page. Alright, so for this one, we started out, we noticed that the perimeter here was 16. They gave us that the radius was going to be x over 2. Now guys, they didn't necessarily give us the radius directly. They labeled it in there, but they didn't tell you it was the radius, so you got to look for that. Alright, so what I saw a lot of you guys doing, which was good, is we used two different things. We wanted to maximize the area. So the area is half of pi r squared plus the area of the rectangle on the bottom. Okay? Now, obviously, I don't want to differentiate that yet because I don't have a function a in terms of x. Okay? Now you don't have to put it in terms of x, but that'll probably be easiest, alright? Come on, guys, stay with me here. Okay? So, we use the perimeter. The perimeter was 16, and that is half the circumference. So half the circumference is, instead of 2 pi r, it's just pi r, plus the perimeter of the bottom is 2 y's plus an x. Okay? Now we know r is x over 2. So r squared is going to be x squared over 4. So this whole thing is going to be pi x squared over 4 plus 2y plus x, and that equals 16. So now I solve for y, alright? And y should end up being, it was a positive 8 minus
1/2
x over 2 minus
pi x squared over 4.
So we get x squared, r is just pi over 2.
pi x squared over 8. Okay? Okay?
Isn't it over 4?
Oh wait, hang on. No, that you were right there. I was mixing my area formulas in my that's just a pi x. Alright, so that's just over 2, so now it's over 4. Okay. So now we have something to plug in for r and for y. So down here in my area, now r squared is x squared over 4. So 1/2 is, that's going to be a pi x squared over 8. Plus x times the y we just found. 8 minus x over 2 minus pi x over 4. Okay? I saw some of you then take the derivative right now and you were using the product rule. You don't have to. Just distribute your x. Right? A of x is pi x squared over 8 plus 8x minus x squared over 2 minus pi x squared over 4. Okay? Guys, this is where simplifying a little bit at the beginning will be really, really helpful. Notice I have pi x squared and pi x squared, but one's over 8, one's over 4. So I'm going to multiply this by 2 over 2 and make that be over 8 as well. So my final function, a of x, is going to be 8x minus x squared over 2 minus pi x squared over 8. I had 1 pi x squared over 8 minus 2 pi x squared over 8. That's a negative 1 pi x squared over 8. Okay? So now I'm able to take the derivative without having to mess with the product rule. Okay? And I'm finding the derivative because I want to maximize the area. So I need to find that critical value. So a prime of x is 8 minus 2x over 2, which is just x, minus 2 pi x over 8. Alright, so this is going to be 8 minus x minus pi x over 4. Okay? And then we just have to solve that for when it equals 0. Alright, what'd you guys end up with?
Negative 8 over 4 minus.
Okay?
No, that's not the 4 minus pi. It's
I think you got something.
Alright, if I factor out, if I take the 8 over here, I'll factor out or I'll get a negative, I'll just factor out the x, and I have a negative 1 minus pi over 4. So x is going to be 8 over 1 plus pi over 4. If I cancel out the negatives when I divide. And guys, listen, you could leave your answer like that.
Yeah.
If you really want, you could multiply by 4 over 4. And that would make it 32 over 4 plus pi. Which is like 32 over about 7, which is going to be somewhere around 4-ish. A little under 4. 3 point something. Okay? So that's x. We should go ahead and find y as well. And if you want to really be safe to make sure you got all of it, you'd get your r as well. So it's that many feet. R is exactly half of that, so that's just 16 over 4 plus pi feet. And y, we'd have to go back and plug in back there. We could figure out what that is, okay? So. Okay, so one more example here. A right triangle is formed in the first quadrant by the x and y axes, and the line through the point 1, 2, as you see up here. So here's our right triangle, and here's our hypotenuse. Now, if you notice here, this side, because that's the point x0, this side is x, this side is y, and that means the hypotenuse is going to be L, which is the square root of x squared plus y squared. However, we want to be able to write L as a function of x in order to optimize, or in this case, find the minimum length for this. Okay. Now, one thing that we can note as well here is that because it has to go through the point 1, 2, there are a couple of parameters here, and one of those is that x is going to have to be greater than 1, and y is going to have to be greater than 2. So that will give us some guidance later on when we're finding an answer. Okay, so how do we get this all in terms of x? Well, it all goes back to the fact that this is going through the point 1, 2. And we're actually going to use a way to represent the slope in two different ways. If we tried to just take the slope, say from 1, 2 to the point x0, and then use point slope form, we'd actually end up coming out to 0 equals 0, which is a problem. So what we actually need to do is we're going to do that slope. The slope would be negative 2 over x minus 1. Okay? 0 minus 2 is negative 2. X minus 1 is your run. Alright? However, we can also represent the slope going from this point 0y over to the point 1, 2. And in that case, we have y minus 2 over 0 minus 1. Okay? Now this is important because now we have an equation with x and y. We can solve this for y, and as a result, we can then plug that in over in our equation for L to make it a function in terms of x. So, first thing I'm going to do is multiply by negative 1. So y minus 2 is now positive 2 over x minus 1. And then I'm going to add 2. So y is 2 over x minus 1 plus 2. Now, one thing I'm going to do here that might make my life a little bit easier later is I'm going to multiply this by an x minus 1 over x minus 1, get a common denominator, and now I can write y as 2 plus 2x minus 2, which is just going to simplify to 2x over x minus 1. So now I know what y is in terms of x. So I'm going to plug that into our function. I have the square root of x squared plus that 2x over x minus 1 squared. So that's going to be a 4x squared over x minus 1 squared. Okay. So there is our function L, the length of the hypotenuse, as a function of x. Now part B here says to use a graphing utility to graphically approximate x such that the length of the hypotenuse is a minimum. Alright, so what we would do here is basically we are going to we're going to plug this into the calculator, graph it, and then find that minimum point. Okay, now we could do this with derivatives and trying to find where that equaled 0. This one is so complex that we're just going to use the calculator to help us out. Okay, so I've taken the liberty of doing that already. I'm going to insert this image of the graph, and I've already actually identified it. Now on your calculator, you'd go to your y equals, you'd plug this in, and then you could do a calculate min. Now you can see here, this is kind of a wild looking function, but I've been able to find the minimum value here when x is 2.587. Okay, so that's going to give us the minimum length of the hypotenuse when x is 2.587, which is, as you can see, about what it's drawn as. Okay, now that means that y, or that means the length of the hypotenuse is 4.162. All right, so notice what we're finding here. This is x, and this right here is L of x. All right. Don't be careful not to make that your y value, okay? Because the y value is 2x over x minus 1. All right. So the y value is actually going to be 5.174 over 1.587, which is 3.260 if we go to 3 decimal places. Okay, so now it makes sense here that if we now made the hypotenuse a minimum, okay, that is, you know, the x is 2.587. That's the x that's going to make our length of our hypotenuse the minimum. We also here have part C. It asks for us to find the vertices such that the area is a minimum. So now we're having to write the area of x as a function of x. So area as a function of x. You guys know with the triangle, it's 1/2 base times height. So we have 1/2 times x times the y. Well, we already know y is 2x over x minus 1. Alright, so here's our function. The 2's are going to cancel, so it's just going to be x squared over x minus 1. Now this is a simple enough function. If we want to minimize the area, we're going to find the derivative of a by hand this time. So a prime of x, use the quotient rule, is going to be 2x times x minus 1 minus 1 times x squared all over x minus 1 squared. Okay? So we have here a prime of x, which is 2x squared minus x squared. So x squared minus 2x over x minus 1 squared. Okay, so if we are then going to find the critical points in order to find our min, we let the whole function equal 0 or be undefined. So it'll equal 0 when x is 0 or 2, and it'll be undefined when x is 1. Now, the thing with this is, remember what we said before, x has to be greater than 1. Alright, so really, if we're doing a sign diagram here, we can test all these intervals, but really the only one of these that would even be a possibility to give us the minimum area would be x equals 2. Now I don't want to jump to conclusions there, but I'm pretty sure that's going to be my solution. Let me just double check by plugging in 1.5 for x. If I plug in 1.5 into the derivative, I'm going to get 2.25 minus 3, so that's negative, over something squared, which is always positive. So I know this is negative, so that's going to be decreasing. So that's a good sign. We're decreasing to get to 2. Now, in order for 2 to be the minimum, it has to be increasing on the other side. Let's see if that happens. If I plug in a 3, I get 9 minus 6, which is positive, over what's always a positive, something squared. So that is correct. This is positive, and we just showed that x equals 2 is the minimum. So that means the vertices of the triangle, don't forget to answer the question, x is 2, so that means we have the point 2, 0. Of course, 0, 0 is where the right angle is, don't forget that vertex. And then we have 0, y. Well, y we know is 2x over x minus 1. So 2 times 2 is 4, over 2 minus 1 is 1, 4 over 1 is just 4. So that is the triangle that will meet all these criteria. It's going to hit the x and y axis, it's going to go through the point 1, 2, and it's going to have the smallest possible area.